All right. So today we get into the last method of solving the system by what we call combination or elimination. All right, and this is the second method that is we use solving things algebraically. So the first thing we're going to teach you is the combination method, and that we use. Then we're doing the elimination method, and again, both methods are um, used when solving. So this first four problems, we're going to use the combination method. The second four problems, we're going to use the elimination method. And you can kind of pick an idea of which one you like the best. So combination, think of the word combine, okay? That's what we're going to do is we are going to combine, okay? We are going to combine things by adding, okay? So, for example, we combine the x's, right? So you have negative x plus x is 1, and then we have the plus sign, and then we're going to have the next set, which is 4y plus 2y, and then that's going to equal the next set, which is 7 plus 5. So we're going to combine all the like terms of the standard form. Okay. Well, the negative x plus x, when you do that in the parentheses, is 0. This is 6y. This is 12. So literally out of all that, we get 6y plus 12 when we combine the equation. Well, basically, the x takes itself out. Okay. So when it does that, we can go ahead and solve for y by dividing by 6, and y is 2. Okay. So now that we've done that method, what we can do now is I can go back to one of the previous equations, plug my y in, just like I did with substitution. Okay. I can plug my y in and solve. So let's use the second one, which is this equation right here. We're going to plug, it's going to be x plus 2 times 2 equals 5. Well, 2 times 2 is 4. So when I subtract 4 to both sides, x equals 1. Okay. So we have our potential coordinate here. Because remember, we still write these as coordinates. So we got to plug it into the other equation here to make sure it works with both points, and then we got our answer. So x is 1, negative x is negative 1, plus 4 times 2 equals 7. Well, negative 1 plus 8 equals 7. It checks. So our answer is the coordinate 1, 2. Okay. So that is the combination method. So let's try the next one. Okay, we combine these terms. All right. Now again, when we add them, if I add them here, nothing goes away. But what I need to do in the second one is I need to look at, if you look at the y column, I got the same number, right? But they're the same sign. So if I take this whole expression and multiply it by negative 1, okay, so I got 2x plus 3y equals 4. I can't eliminate anything when we combine because they're the same sign. But now if I multiply through by negative 1, now when I add, you see I can get rid of the y, that's a positive 8 now. All right. So now when I add, I'm going to add 2x, basically plus, it's basically a minus 5x because plus and negative is a minus, plus 3y minus 3y equals 4 plus 8. Okay, because remember, we're combining these. All right, so I do that, I get negative 3x plus 0 equals 12. The y's are gone. And I can solve for x by dividing by negative 3 to get x equals negative 4. So again, now that I find my answer, I can go up to one of the equations. Let's just use the first one. So 2 times negative 4 plus 3y equals 4, and that's negative 8. So when I add 8 to both sides, 3y equals 12. When I divide by 3, y equals 4. So we hopefully here got our possible solution. We just got to check it now in the other equation, which is going to be the original one here. Okay, so 5 times negative 4 plus 3 times 4 gives me negative 8. Well, 5 times 4 is negative 20 plus 12. When I add 12 to negative 20, I get negative 8. So it does check. So that means the answer, the solution to this system is the coordinate negative 4, 4. So remember, when you are finding a solution to this system, it is the place where these two lines do intersect. Okay. So let's continue on with the combination method. Okay. Now remember, the first one, we can just straight up add because my x's, if you look at them, if I erase this here, you can see it. My x's here were opposite signs. So I can just add them. And the second one, my y's were the same, but they had the same sign. So we had to multiply by negative 1 so we could get that combination method to get rid of one of the variables. Well, I got the same thing in number 3 here. My y values are the same. They're both negative 3. So if I multiply, I'll just do this one this time just to show you. It doesn't matter which one you do. If I multiply every term by negative 1, right, I get 2x. This is going to be negative 2x plus 3y equals negative 4. So now when I put the other ones, I just copied the same equation. So now when I go ahead and combine, I'll get rid of my y's because I got negative 2x plus 5x plus 3y minus 3y and negative 4 plus 7. So the y's go away. That's 0. So I get 3x here equals, and negative 4 plus 7 is 3. So when I divide by 3, x equals 1. All right, so I'll go back up to one of my original equations here. I'm going to just do a little erasing so you can see. All right, we're going to choose the first one because the numbers are smaller. So if I plug in 2 times 1 minus 3y equals 4, well, 2 times 1 is 2. All right, so when I subtract 2 to both sides, I get negative 3y equals positive 2, and when I divide by negative 3, y equals negative 2/3, or we can do it as a decimal, negative 0.6 repeating. All right, the decimals are easier to use, especially when you're in the algebraic modes, because then you don't have to worry about the common denominator stuff. Okay. So let's plug it in to make sure it works. Well, we use the top equation for the first one, so we're going to use this equation to check it. All right. So 5 times 1 minus 3 times negative 2/3, which just works out nice because the 3's cancel. It's nice. Equals 7. Well, 5 times 1 is 5. 3 times negative 2/3 is negative 6/3 or negative 2, right? Well, we got the double negative, which means we change it to a plus. 5 plus 2 is 7. 7 equals 7. So we have the right answer. And I can write my answer 2 ways. I can write it using the fraction. I love this board. Or I can write it using the decimal. Either way is correct. Okay. That is where the two lines intersect. Now, I need to manipulate the second equation because if I combine right away, if you look, I do not have a way to get rid of a variable. So I try to look at, okay, what numbers can go into what other numbers evenly? What smaller number can go into what bigger number evenly? And if I look at this, if I want to eliminate the x's, I can multiply by 5 because I'll have a negative 5 at the top and a 5 on the bottom. Or if I do the y's, I can also do that. So let's just multiply the top one by 5. So when I do that, I get negative 5x plus 2y equals 25. Copy the second one because I'm going to eliminate my x's here. I wrote 2y, that should be 10y. Okay, so now I can do my combining. I got negative 5x plus 5x. And we're going to add that to 10y minus 10y equals 25 plus 11. So this becomes 0. This becomes 0. This becomes 36. So if you look at it, both my x's and y's got eliminated here. I get 0 equals 36. Well, 0 does not equal 36. Okay, so that means there is no solution when you have that. When we lose our variables, okay, and the left side doesn't equal the right side, that means no solution because these are parallel lines. There's not one point that's going to work for both equations, but they're parallel. All right, so that is the combination method. Now, the elimination method, this is a little different, okay? We're going to do something similar to it, like we did the first one. So if you look, instead of writing it out like we did in the combinations, you'll see what happens here. If I look right away, when I add the two equations together, I can't get rid of anything. But what I need to do, right, is I need to change one of the, well, 2 can't go into 3 evenly, but 2 can go into negative 6 evenly. So if I multiply this whole thing by 3, I get 6x plus 6y equals 15. I'm going to recopy the second one because if you look at it, I'm going to eliminate the y by adding. I have opposite signs here. That's what we want. Same number, but opposite sign. So the y's become 0, and I'm left with 9x equals 27. Because the y's are gone. All right. If I divide by 9, x is 3. So now I'm going to go over here to one of these equations. I'm going to use the first one and plug 3 in for x. And I get 6. So when I subtract 6 to both sides, I get 2y equals negative 1. So y equals negative 1/2, right? Or negative 0.5. So now I need to use the other equation and plug that in to make sure it works. Well, 3 times 3 minus 6 times negative 1/2 equals 12. Well, 3 times 3 is 9 minus 6 times negative 1/2 is negative 3. Because negative 6 over 2 is negative 3. So I got the double negative, which means we add 12 equals 12. That checks. And our solution is the coordinate 3 negative 1/2. Or again, I can write it like this also. Either solution works. And again, so we kind of eliminate that way by stacking them up. It's like the old traditional adding. Okay. So again, you can kind of take the method that works for you and use it. So number 2, if I look, I can't get elimination right away by adding anything. So I gotta multiply one of the equations to get an equivalent equation. So 3 can't go into 5 evenly. However, 1 goes into 4. So if I multiply the top, now if I multiply by 4, I get the same sign. So I'm going to multiply the top by negative 4. All right, when I do that, I get negative 4x minus 12y equals negative 16. And when I rewrite the other one, you can see now by adding the two equations together, I get rid of my x's. Because these are inverses, so these are gone. Negative 12 plus 5 is negative 7, and negative 16 plus 2 is negative 14. So when I divide by negative 7, y equals 2. I'm going to go into one of my equations. The first one looks easier. So I'm going to take 2 and plug it in for y and solve. 3 times 2 is 6. I'm going to subtract 6 to both sides, and I get x equals 2. That should be negative 2, sorry. 4 minus 6. So I got 2, and I got negative 2. All right, so we're going to go to the second equation, 4x plus 5y equals 2. We're going to plug in x and y. So 4 times negative 2, that replaces x, plus 5 times 2 equals 2. Well, 4 times negative 2 is negative 8. 5 times 2 is 10. When I add 10 to negative 8, I get 2. It checks. So that is our solution. And our solution is, again, that coordinate of negative 2, 2. That is the intersection point. Okay. Always looking to find ways to get that elimination, adding the two equations together. You need the same number, opposite sign. So again, if I look at number 3, 2 can't go into 3 evenly, but 1 can go into negative 2, right? If I multiply this top equation by 2, I get 4x plus 2y equals 5. Then if I just rewrite the bottom one, if you notice, by adding now, I can get rid of my y's. They're opposites, they cancel out. So 4x plus 3x is 7x. Oh, I think I made a mistake up there. That shouldn't be a 5. That should be a 10, because 5 times 2 is 10. So 7x equals 25. And when I divide by 7, x is 25 over 7. Or, I think it comes out to, grab my calculator here, 3.57. Yeah, it's kind of, so we're just going to make it, we're going to kind of take this a decimal here. Make it 3, not repeating, 3.6. Okay, so there's our x. Now let's see what happens when we plug it in for y. So if I take, we use the original first equation. Okay. So 2 times 25 over 7 plus y equals 5. Well, that's 50 over 7. If I subtract 50 over 7 to both sides, 50 over 7 is like 7.142. So if I take 5 minus 7.1428, it's a big, long, repeating decimal, I get roughly about negative 2.1 for the y. So I have 3.6 and negative 2.1. So now what I need to do is plug it in. Now I should be close. I'm probably not going to get the exact answer because I rounded these decimals. That's okay. But if I plug them in, 3.6 for x, negative 2.1 for y. So 3.6 times 3 is 10.8 minus 2 times negative 2.1 is negative 4.2. I might have rounded this perfectly. And if I add, this becomes a double negative, so it's a plus. So if I take 4.2 plus 10.8, I get 15. It checks. And this crazy thing is our answer of 3.6 and negative 2.1. That's sometimes the good thing about solving things algebraically. That would be a tough graph to see. Very tough graph to see. All right, last but not least, number 4. Now, here's something that happens where now instead of multiplying one equation to get that elimination, sometimes you have to multiply 2. Because 3 can't go into 4 and 4 can't go into 3. However, 3 and 4 have a greatest common factor of 12. So now I just got to figure out, okay, what do I want to multiply by? Which one do I want to eliminate, x or y? So let's say I choose x. I got to make one of these, because if I have 12x and 12x, they don't eliminate by adding. So I got to make one negative. I'm going to multiply this top equation by negative 3 and the bottom one by 4. When I do that, I get negative 12x minus 9y equals positive 54. Because negative 18 times 3 is that. Trust. Now when I multiply the bottom, I get 12x. So you see by adding here, we've gotten rid of our x's. Plus 12y. Sorry, 16y. 4 times 4 is 16 equals 12. So this cancels out. Negative 9 plus 16 is 7. And 54 Oh, I see what happened. That's, this is an equal sign. So this should be a negative 54. Okay, it's all good. So negative 54 plus 12 is negative 42. When I divide by 7, 42 divided by 7 is negative 6. Okay. So I'm going to go back to one of my original equations and plug in negative 6 for y. Let's just use the top one. 4x plus 3 times negative 6 equals 18. Well, 3 times negative 6 is minus 18. So I'm going to add 18 to both sides, get 4x by itself. Divide by 4 to get x by itself, and 36 divided by 4 is 9. So hopefully I got my two answers here. I got to use the second equation now and plug both of them in. 3 times 9 plus 4 times negative 6 equals 3. Well, 3 times 9 is 27. 4 times negative 6 is minus 24. And 27 minus 24 is 3. So guess what? It checks. And our answer is 9, comma, negative 6. And there is the intersection point where those two lines meet. Right? So again, when solving these equations, okay, whether you use the combination or the elimination method, again, you've got to eliminate, you got to get rid of one variable. And you got to kind of do that in a creative way sometimes by either multiplying by a positive, negative number, but we're always adding the equations together. All right, so I hope you found this video helpful and it can help you with your homework.